so this is a Hello World smart contract following the framework. And so a smart contract is a JavaScript module, and it exports a start function. And we have not just any JavaScript, we recommend this hardened JavaScript, and in fact, we enforce it in various ways. Because ordinary JavaScript, somebody could replace the array.push method, and then you'd have this very confusing world to live in. So we don't let that happen.
Quick question for you, Dan. And so in Agoric, you have the secure ECMA script, right? And then Jesse is like a subset of that. So this contract kind of written in Jesse, so to speak.
Yes, it is. In fact, I can have the tools check that.
Okay.
Let's see if I violated Jesse anywhere here. So if I
nice.
Yeah. So there's a lint profile for Jesse, and I happen to be I haven't strayed outside of Jesse here.
Okay. Excellent.
So you just write
briefly
go ahead.
Can you briefly describe what Jesse is?
I can. You start with the whole world of messy JavaScript.
Right.
You take out non-static scoping, things that modern programming languages don't have. So you're in strict mode. You take out some stuff that's dangerous that I won't mention. Well, I mean, object capability security is what you work on in this SES realm here, or box, if you're familiar with that. Okay, so that caller and callee or syntax and things like that. These are mostly globals that you just don't get when you're in Jesse. There's var and this. They're also outside Jesse and class and super. And then proxy and realm and symbol and things like that. And then Jesse is this subset of JavaScript that we recommend so that humans can write smart contracts, with a chance of getting it right.
Cool. So if you know JavaScript, you might try using some of those other features that are unavailable, but it seems the learning curve should be somewhat fast for figuring out, oh, I can't do it that way. So, okay.
Yeah, so, if you're in the editor here and you write, what's some syntax that you're not supposed to use? I can't even remember any because my brain is trained this way. Anyway, you'll get red squigglies underneath it, stuff like that. So you get real-time feedback. One of the nice things about working in the JavaScript world is, oh, right. So if I write, what's it telling me here? Class is not allowed Jesse. Define a maker function. Yeah, thanks for the clue.
Oh yeah,
write
nice
more bugs. Write
clues.
more bugs. Redefine whatever Thomas just said about redefining a variable.
So we have mutable variables. You can redefine variables, but you can't do things like if I try to object assign. Now I might go over time if I entertain all these questions in line. I'm happy to do it.
Sorry, that's how we are sometimes.
Sure, I don't mind.
That's how we roll.
So this is, if you just fire up node, this would work, I think. And then if I say 1, 2, 3. Oh, sorry. Array.prototype. Yeah. See? So you don't want that.
Nice. Right.
But if I do here, if I do that, and if I, oops, yarn test, it'll blow up.
Cool.
Can't do that. But if I take this out, if I just run the test so that it runs the tests every time I save. So I'm winning. Right. So we have JavaScript with this fun little edges around it. And to do a to do a Zoe smart contract, you export a start function, and it gets access to something, but we're not going to use it in this contract. We're going to have a value that we can change that starts with hello world, and we're going to have a public facet which you give out widely, and anybody can get the value. But then there's a creator facet, so only the guy who creates who instantiates the contract gets access to the set method and can change it. So then the tests, we write them with a thing called Ava, which is a reasonably popular testing framework, and then we customize it a little bit. And you make a fake Zoe service for testing purposes, and then you get the value and you test it works, and then you set it, and then sure enough that worked too. Now this little E widget here, it might be a little strange. So the contracts in Zoe and stuff operate in different VATs, and VATs are kind of like iframes or something. So this call here goes between one sort of event loop and another. And what happens is the method and the arguments and stuff get serialized up and sent over to Zoe and come back, and it's done asynchronously. So you get a promise for the result. So we avoid reentrancy hazards there. So that's the way the distributed computing works. You just have to write E around stuff. And for the price of that, we can go within the same machine or across machines or across blockchains or anything like that. So the asynchronous messaging works across the whole fabric. Okay, so that's hello. And then, but this doesn't have any electronic rights or tokens or money or anything like that. And so here's a slightly more involved contract. Oh, that's testing it, sorry. Here we get points for primes, and the way this works is if you can guess the next prime number, you get, if you guess the first prime number, you get 1 point. If you guess the second prime number, you get 2 points, etc. And so I actually got the prime generator out of Stack Overflow, but it was written in Python, and JavaScript doesn't have set default, so I had to add set default. This just takes a map and a key, and if the map has that key value, then it returns it. Otherwise, it assigns that key to the default and gives you back the default. And so this is just a generator for prime. So actually, if I put Jesse check on top of that, I think I won't be able to use generators. Yeah. So this is rocket science a little bit. So you're kind of advised against it because you might be difficult to read the smart contract, but you can still do it. So that generates primes, believe me. I tested it and everything. So that's just ordinary JavaScript programming up there. And so now we start our contract. And so earlier we didn't make use of this widget that was passed in, and this is our connection to the Zoe world. This is called the Zoe contract facet. And one of the things you can do is make a mint. So we're just making up a new token. I think you called them anyway, ERC20 token, and it's pretty similar. And then we're going to get a thing called a brand. Whenever you make a mint, there's a mint and an issuer and a brand is sort of how you recognize this. It's a little bit like the contract address in Ethereum, but it's just a JavaScript object. All right, so then we got our generator, and when the way the clients interact with contracts that make offers and stuff like that is an offer handler comes in. Sorry, we have a public facet, and then the clients can make an invitation, which is part of this business of composable smart contracts, which I won't even get into. That's a whole other thing. You can when you're participating in a contract, you can take your seat in a contract and sell it to somebody, and then, you know, so that things compose. So they, on the public facet, they call make invitation. So they get an invitation, and then they can make an offer. And when an offer comes in with a guess, if they got the guess right, then we mint some tokens and give them to them, and we tell them that they won. Otherwise, we say guess again. And if I hit save, it'll run the tests again. And so we can see that when the guess was 2, the guy won and he got 1 token, and the guess 3, and the guy won and he got 2 tokens, and then the guess 4, and nope, that wasn't right. So that is a little teeny, it's like a faucet where you have to do a little bit of computing to get your money. So that's a, you know, a 20 or 30 line smart contract. And then we've got auctions and all kinds of financial instruments built in so that you can just use them instead of having to build them.